Okay, so today we're going to be looking at section 4.4, solving rational equations. So first off, what does it mean to solve an equation graphically? We've answered this several times, but here it is again. The answer to this question is to look at the equation as a system of equations where the left side of the equation is one function and the right side is another function. From a graphical point of view, these two functions will be equal when their graphs intersect. So here is an example we're going to do. I have these two, this equation. Here's the left side, here's the right side. So on a graphing calculator, whether in Desmos or on one of the TIs in class, you can actually graph both of these things on the same coordinate system, as in this case right here. So I graphed it on the calculator so you can see what it looks like. And what we need to do is we're going to use our trace feature and stuff in our understanding of how this left side here, this rational function can be graphed. And we're going to put it on this coordinate system over here so we can see where they intersect. So this point right here is going to be our solution, and we're going to determine that on the calculator also. Let's draw this picture in here. Let's get some values that we want to see. And so in the trace feature, we can just go down the line and kind of see what we're looking for. I already know, for example, in this equation right here, I already know where some of the values are. So for example, we have a vertical asymptote when x equals 3. So we can put that in right now. So I go over here to 3, and I can draw my dotted line here. Okay, we can do the horizontal asymptote because the 2 degrees are the same. It's the leading coefficients, which is 1 over 1. So we have a horizontal asymptote at 1. We draw that in. This helps us position our stuff. Then I can just use the calculator trace feature and I can get some more values on here. I'm just looking for points, so I can start at we can start at 0, and I get about 2/3, negative 2/3. So there's a dot right about here, and I can just go down the line. I can type in 1, negative 1.5. I can type in 2, negative 4. I can type in negative 2. Start skipping some. Type in negative 4, and about a quarter. So there's that curve that we're going to be drawing here. Then I can do this one over here. We can go to 4. 4 goes to 6. And 6 is 2 2/3. And then we can do 8 is at 2. And I can do more, but that's enough for now. I can see kind of what's going on. And so what I do is just draw this curve according to what we know how to draw. And we can draw this side over here. And then we want to draw the right side, which is y equals 4. So that is a solid line. So this is y equals 4. This is y equals x plus 2 over x minus 3. And this is my point of intersection that we're trying to find. And then on the calculator, it would be much easier to determine where it is. So remember how to do that. We go to menu. We go to analyze the graph number 6. And we want to find intersection, which is number 4. This is a standard technique that is used in many math classes from this point forward. I want to make sure this dotted line is to the left where I think the point of intersection is, the lower bound. Hit select, and then it changes to the word upper bound, and then I can slide it across. Once I get past that point, it'll give me a value. That's my answer right there. So this point right here should be at 4.667, 4. So that is that point of intersection right there. That is my solution. So x equals basically 4 2/3. Okay, so that's how that works graphically. Okay, you want to make sure you know how to do that with the calculator. You can also do this on Desmos, and Desmos is a little bit easier because all you gotta do is just touch where they cross, and it gives you that point. So when you're at home, you can use Desmos, but you need to learn to use my calculator here for in-class work. The next part down here is, well, how do I solve and get that answer algebraically? So how do I solve these things algebraically? What am I going to do? What is my technique? Okay, so to solve algebraically, we have certain guidelines we want to follow. Very straightforward. And because these are fractions, you're literally using the same techniques that you would have used back in Algebra 1 in eliminating fractions. So you want to multiply both sides of the equation by the LCD. So I'm going to multiply both sides of the equation by the LCD. Okay? And that is going to eliminate your fractions if you do it properly. Then you just simply solve the equation that you get. And the last thing, the most important thing you have to do is you need to check for extraneous solutions. What are extraneous solutions? Extraneous solutions are basically false answers. They are false answers. What do I mean by that? Because you're introducing more variable to the equation itself, you could be introducing a false answer. So when you solve the equation, you might get an answer down here that says x equals 3, but if I plug in x equals 3 up in here, see, I can't plug in 3 up in here because that would be a 0 in the bottom of this fraction, which means you can't have 3 as a solution. And so that's called an extraneous solution. So you would just cross that out. You don't circle that as an answer. You only circle the answers that are true. Okay? So let's solve this. So the LCD is pretty straightforward for this. The LCD is going to be x minus 3 in parentheses. And so we put both sides. I would suggest you get used to doing this. Put both sides of the equation in parentheses and then multiply by the LCD. As I multiply these two things together, the x minus, this is a fraction, x over 1, this over 1. You multiply these two things, these are going to reduce out, and I'm simply left with x plus 2. Over here, I just distribute the 4 throughout that, and I get 4x minus 12. So I'm going to solve this for x. So since it's linear, I'm going to subtract the x from both sides, and I'm going to add the 12 over here. And so over here, I get 14, and over here, I get 3x. Divide both sides by 3, and I get x equals 14 over 3, which is 4 2/3. So that is how I can get my answer. Okay, that is the algebraic techniques for solving rational equations. Finding the LCD, multiplying both sides of the equation by that LCD, solve the resulting equation, and then check your solutions for extraneous answers. Okay, that is the process we're going to follow, so let's keep on going. So I have another example I want to look at. It's the word problem, how we can use this in the real world. Okay, and so here is a problem right here. You're going to start seeing a couple of word problem things on this assignment. You want to make sure you know how to do these. These are also going to be possible test questions. Your engineering design company has been hired to design a soup can for Yummy Soups. You want to design a soup can that has a volume of 350 cubic centimeters, but they want to use the least amount of material possible. Draw a sketch of your soup can and find its dimensions. Okay, so a soup can basically is a cylinder. Okay, the important parts of a soup can or a cylinder is I need to know the radius and I need to know the height of this thing. So there's a picture of my soup can. The dimensions are these two values right here, R and H. Look for the clue words. Volume is pretty obvious. So we want to be able to find the volume of a cylinder. So you should know the volume of a cylinder. Okay, it's the area of the base times the height. as the volume for a cylinder. The next one here is kind of subtle, and it's this thing right here, this little bit right here, least amount of material possible. Okay, that is also a clue word for a formula that we're going to need. Okay, it does two things. The word least amount tells me something, and the amount of material is the other thing. The material means what it took to make this can. If I want the least amount of material, then this is referencing what's called surface area. Okay, so what is the surface area for a cylinder? Well, to help you see that, let's cut the cylinder up. So imagine taking the cylinder, using some cutters and cut this thing right down the line, and then opening everything up and laying it flat. This is actually what's called in mathematics called a net. And so here is the whole body side laid flat. Here is one of the bottoms or the top. Here is the other one. So this is the bottom and the top. It has a radius. And this part right here, that's H. Okay? So cut the can, cut the tops, and there it is. Okay? So what is the surface area? Okay, well, surface area is the area of all the surfaces. I have two circles here. So my surface area has two circles. And with that, we're going to add whatever this rectangle is, because this is a rectangle when you lay it flat, and I know that that is H. So the next question is, what is this? Well, where did this come from? This length right here was literally what was wrapped around that circle right there, which means this distance right here is literally the circumference of that circle. And the circumference of a circle with radius r is 2 times pi times r. So that's the surface area of a cylinder. And we need to use both of these equations to help us answer this problem. This is called basically a max-min problem. In this case, I'm asking for the least amount. This is what indicated it to be a minimum problem. I want the smallest amount, the minimum of material. So I'm going to minimize the surface area. In a max-min problem, you have different types of equations. One is the primary equation, which is the one you're going to maximize or minimize. So the surface area is our primary equation. This is primary. This is the one you're trying to maximize or minimize. This is your equation that maximize or minimize. Okay? So what does that make this equation? Well, this equation becomes what's called the secondary equation. Okay? So this is the secondary equation. Volume is pi r squared h. This is your secondary equation. And its job, it is used to make the primary have only one variable. So it's used to eliminate a variable. So over here I have, oops, I forgot H here. There's two variables, there's R and H. This equation, to minimize it, I have to have only one variable, either the R or the H. So this equation is used to solve for one of those variables that I can then substitute over here. And they helped us do that because they told us what kind of volume I wanted. So since the volume is that, this is 350, and this is pi r squared h. And so you can see that it's very easy to solve for h. I don't want to solve for r because there's two places over here and they're two different kinds. There's an r squared and an r. It's a little bit harder to do. So it's easier to solve for the h, which means this quantity in the front has to divide out over here. So I get h is 350 divided by pi r squared. And that's the purpose of the secondary equation. I'm going to take that quantity and substitute it over here into my primary. 2 pi r squared plus 2 times pi times r times 350 over pi r squared. And then I'm going to simplify this expression over here. 2 times pi r squared. Here, the pi will reduce. One of the r's will reduce. This 2 times that gives me 700 and an R on the bottom. And that is the equation you were looking for. I can now minimize this equation, okay, which means find the minimum value. To do that, you want to graph it, okay? Use a calculator to graph it. It's the easiest way to do it. We don't need to do this by hand yet. You can do it later on in other classes if you decide to do it. There's techniques we can use. So we're going to graph this. I've already done so. And I actually found it. So let me go ahead and do it again. You can kind of see how it looks from start to finish. So down here, I'm going to graph this out. I'm going to type in what we see. 2. The pi is this button way down here. And then instead of R, I'm going to use X. And there's my squared. Then I'm going to go plus, and then I'm going to type in a fraction. 700 divided by X. And I'm going to hit enter. And you'll see this. Okay? Now, we need to think about this for a minute because this is a real life problem. The X value on my graph calculator is the radius, and the radius being a negative value. No, so you see over here, these are all negative values. I don't need these. The other variable is S, the surface area. Can the surface area of a can be negative? And the answer to that one is no also. So when I go to my menu, I can go change the window and see the settings in here. I can change the minimum for the X to be 0. I'll just leave it at 10 for now because I don't know where I need to go. This can be 0 for the minimum on the Y. But what's the Y max? Well, it's pretty large, mainly because we have this 700 sitting right here, this 350 over here. So these are pretty large numbers. I don't know where it needs to go, so I'm just going to pick a large number somewhere. It's 500. Somewhere in between those two big numbers. Let's see what happens. And then I hit OK. And there's your picture. Okay? So this is what you're looking for. And so then down here, you can see this is the graph of all the different surface areas for different values of X. But the minimum is right down here. And then we can use our calculator techniques to find that minimum, which is what I did in the previous screen. So go to Menu, Analyze the graph number 6. And you'll see minimum is number 2. And so here's the line with the finger again. And then we have the lower bound. As long as I'm to the left, I can hit OK. So it switch to the upper bound, just slide across. It will stop. When it stops, you're to where you need to be. And then you can actually move this. When the hand comes on, you can hold it down in the middle. It'll move it. So you can read the numbers. So there it is. So what is this telling me? It tells me that the radius is at the surface area is at a minimum when the radius is 3.819. And the minimum surface area is that number right there. So we have a minimum at R equals 3.819 centimeters. And the minimum is 274.933 square centimeters for the surface area. Okay, so this is the surface area. Is that, and this is where it occurs on the radius. So we wanted to find the dimensions, so I found the radius. I need to find the height, which is using this formula right here. So I can open up a new screen, and I can type this in, fraction 350 pi, and then R was 3.819 squared. And so then I get this answer here for H. So H is going to be 7.639. R is 3.819 centimeters. And those, and those are the dimensions of your cylinder. Okay? And then on your paper, we would need to transfer this graph over. And you can do that by simply, come over here, putting some numbers in here, rescaling everything, and you can find these values. So this would be 1, 2, 3, 4. And you can go up here by, go by hundreds, 200, 300, 400, 500. You can do your own scale if you want. So 3.8 is about 7. So that's the minimum number there. I can use the trace feature to find me more values. So I can go over at 5 and 6 and 7. So 5 is almost 300. 2 is 375. 1 is 706. And I can do 6 is 342. 7 is 4, almost 410 about right there. And so I can draw this curve, minimizing there, coming out over here, going off in that direction like so. And you can name that point as 3.819 and 274,933. So that's the name of that point right there. So when you do a problem like this, you want to draw me a sketch, labeling the minimum point, show all the work that's necessary, find your primary equation, secondary equation if it needs one. Sometimes they do, sometimes they don't, but that's how you would do a problem like that. Okay, so let me zoom out a bit, you can kind of see it all at once. So there you go. Okay, so that is a max or min kind of a question. I'm going to do another example for you here. It's a problem that we can look at, that I have a set of problems I'm going to help you guys get. This is going to be an example. It's the classwork number 4. And this is the problem on that paper that you will get. 2x minus 1 over x. And this is x squared minus 4x plus 3. X squared minus 2x. So this is just another example to kind of show you how to use the guidelines for solving algebraically. Okay, so the first thing is we got to find the least common denominator. So I usually go right off to the side over here, find the least common denominator. I have an x. I have an x squared minus 2x. This one's factored. This one is not. Now it is. So from these two things right here, I can tell that my LCD is going to be just this bottom one. So that's my LCD right there. I'm going to take that quantity. I'm going to come over here. I'm going to put both sides in parentheses. And I'm going to multiply both sides by that LCD. I'm going to distribute the quantity. Now, I've told you last time that if there's a fraction that has more than one term, it's automatically in parentheses, particularly if it's next to a negative like this. Very important. This is in parentheses. This right here. So when I distribute this to that, I get x times x minus 2 minus this times that. This x will drop out, and I'm left with x minus 2, 2x minus 1 equals. This right here is that, so the whole thing drops out, and I'm left with just the top. So that's how I can eliminate the fraction problem. Let's zoom back in a bit. Okay, so now our job is to solve this equation right here. So normal techniques, distribute everything, combine like terms, and we get this right here. Be careful with this concept right here. So you have a product, but I have a minus sign here. It's best to multiply this stuff out first, like so. Add another set of parentheses, multiply this out. Minus x minus 4x plus 2. I'm not worried about that side yet. And then distribute the negative sign through. You don't want to make sign errors. Don't do it in your head. Write it out. Okay. So now I've got it all cleaned up. There's no parentheses anymore. All I got to do now is combine like terms. I have a negative x squared. I got 4, 5 minus 2 is plus 3x's minus 2. And then I have this side over here. So I have a quadratic, which means everything goes to one side equal to 0. I want to have the squared term positive, so I'm going to move everything to this side over here by adding the opposite of everything. I'll have an x squared minus 3x plus 2 gives me 0, 2x squared minus 7x's plus 5. Okay? So, and I factor this. I need to solve this. So I either factor it or use the quadratic formula. So try to factor it first. I need to find factors of 2 and 5 that will add and give me a 7. So that right there is 2, that right there is 5, and they can add and be 7, and they're both going to be negative. That tells me that this quantity, that x equals a negative, so this right here, solve this for x, and you're going to get 5 over 2, or I'll get x equals 1. Okay, and we want to make sure that when we plug this in, we get proper answers. Okay, and does this work in both cases? And you check them all out, you plug it in, and you realize that yes, they will. I'm going to save some time in this video, but if I check them both, they both work, and so these are the two solutions, and you circle both of them. Okay, but you do want to make sure you check them. Particularly if they plug in a number in the bottom, it becomes a 0 in the bottom. It means it's going to be an extraneous solution. So double check everything and make sure it's there. We'll do more problems together in class, and this ends this video.